आपका पेन ड्राइव यहाँ देखो, यहाँ ये दोनों ऐप पे होगा। आपको देखना है क्या आपको? ठीक है, घर से देख लेते हैं।
Will you start, sir?
Yeah, we can start.
Yeah.
Secretary Saab, whether you can start, Dr. Ravi? Yes.
Okay.
Yes.
Namaskar. Very good morning, good afternoon, good evening, depending from where you are attending this one. So today is the formal inauguration of IWM-7. So respected all our dignitaries, Honorable Minister of Earth Sciences, Secretary Ministry of Earth Sciences, Dr. Ravi Chandranji, LOC, NOC Chairman, Dr. M. Mahapatra, DGM, IMD, and PR to WMO, all our distinguished panelists from WMO Secretariat, WRP, WCRP, and all our chair, International Committee, Dr. Tyagi sir, Professor C.P. Cheng, and all our respected delegates. So this is a formal inauguration of IWM-7. This is the 7th in series of IWM, International Workshop on Monsoon. And this every 4 years it is arranged, and it was initially planned to conduct last year. Unfortunately, due to COVID situation, we could not arrange it. And at the same time, though we were expecting that this event in New Delhi would be a physical one, but still we could not manage it. So somehow, without further delay, we are arranging this in the online mode. As you know, this is a very important topic, monsoon. The many parts, large parts of the globe, tropical countries are affected by monsoon, and monsoon associated severe weathers are there. Monsoon associated drought, floods, active break cycle, heavy rainfall, all these are challenges that we have seen in last many years. Though it is a historical problem, actually, for particularly country like India, it is long, more than 100 years before it was started, the need of the monsoon forecast. And as you have progressed, we have improved our forecasting capability with the supercomputer. So it is globally, it has improved forecasting, but still due to the climate change and many other complexity of the problem, still a lot of challenges are there before us, like localized heavy rainfall forecasting and its impact. So these are the challenges still remain. So this is a wonderful session. 4 or 5 days we will be discussing this problem, how to improve this national meteor services so that they can be able to handle or manage the disaster associated with monsoon related event. So this is a very wonderful occasion for us, all of us, and I must thank WMO Secretariat and WMO particularly for believing in India to host this event, and also our collaborating partner WWRP, WCRP of WMO, then IITM, the International Monsoon Project Office from IITM, and also the Indian Department, Ministry of Earth Science organizing this, along with Indian Meteorological Society. So it is a many institutes and experts are involved in this thing, planning this event, and now we have prepared all this thing. It is going very smoothly, and without wasting much time, I will request our Director General of Meteorology, Dr. M. Mahapatra sir, for kindly give his welcome address. Over to you, sir.
Namaskar, good evening, good morning to all of you. Respected Secretary, Minister of Earth Sciences, Dr. M. Ravichandran, Professor C.P. Chang, and Dr. Ajit Tyagi, co-chairs International Scientific Committee for International Workshop on Monsoon 7th edition. Dr. Koning, head of WWRP Division, World Meteorological Organization. Dr. Michael Sparrow, head of WCRP Division, WMO. Dr. D.R. Patnaik, distinguished delegates from various parts of the world, members of the International Organizing Committee, Scientific Organizing Committee, National Organizing Committee, and Local Organizing Committee, members and fellows of Indian Meteorological Society, distinguished participants from the organizers like India Meteorological Department, Minister of Earth Sciences, Indian Institute of Tropical Meteorology, and all my distinguished colleagues from the sister organizations, ladies and gentlemen, the dear students and researchers, young professionals, those who are participating in this IWM-7. At the outset, I extend warm greetings to all of you on this auspicious occasion of World Meteorological Day. This year's World Meteorological Day is being celebrated with the theme of early warning and early action, hydrometeorological and climate informations for disaster risk reduction. It is not only a mere coincidence, but it is an anticipated coincidence that IWM-7 is being inaugurated on the day when we are celebrating the establishment of World Meteorological Organizations. The day signifies the unity among the meteorological, hydrometeorological, hydrological, and environmental community. The day recognizes the integration of scientific methods, approaches, understanding worldwide to address the various vagaries of weather and climate. So while you consider the vagaries in weather and climate, monsoon comes to mind of each and every person in the monsoon region. And monsoon being a planetary scale, it impacts almost entire world, starting with Japan to USA. And monsoon is not only confined to the people, monsoon has also the impact on the land mass, ocean, and atmosphere, entire biosphere, cryosphere, and any sphere you consider. The monsoon has been part and parcel of life in most parts of this world, especially when you consider South Asia, Southeast Asia. While monsoon has been a boon as a major source of water, monsoon has also become an adverse factor leading to various types of disasters, especially cyclones, depressions, low pressure systems, convective systems like thunderstorms, lightning, hailstorms, squalls. Monsoon has been a vagary for oceanic activities and opposition to the blue economy. It has deteriorated the socioeconomic conditions of the coastal population because of the many coastal hazards arising out of the monsoon circulations. It also caused significant damage in the past towards our marine activities. But nevertheless, the scientific community across the world has tried their best to understand the monsoon, monitor the monsoon, predict the monsoon, and warn the entire population against the vagaries of monsoon. The search for monsoon goes back to the ancient world, be it the early Vedic ages, written 3000 BC. We can find out the mention about the monsoon, mention about the rainfall, its monitoring, predictions, and early warning services, starting with Rig Veda. Then we came up with Sam Veda, Yajur Veda, and Atharva Veda. By the time we have the Atharva Veda, we could find out the means, ways and means to monitor, to measure. It was followed by continuously by the developing and evolving society. In the medieval history, also you can find out in Indian literature the description of monsoon. Even Chanakya came up with the instrument for measurement of rain, And the basic concept taken by Chanakya for the measurement of rain was a cylindrical object to measure the volume of water. And if you look at the rain gauge in the modern age, it is almost same as the concept was at that time. So therefore, the ancient knowledge has led to building of the knowledge about the monsoon. The emblem of India Meteorological Department says Adityat Jayati Vrishti, which means sun creates rain. So therefore, the people at that time understood the mechanism of rainfall and mechanism of monsoon. Coming to the medieval to recent history, even the poets like Kalidas, they have mentioned about the advance of monsoon over India. They have discussed how the monsoonal winds propagates from south to north, which we are talking of nowadays in terms of intra-seasonal oscillations. He has talked about the winds as the bearer of the clouds, which are utilizing this knowledge while deciding cloud motion vectors. So therefore, there is a continuity from the ancient knowledge towards the modern knowledge, not only in Indian literature. You can also find out the same in the Greek literature and many other literatures. But however, coming to the instrumentation period, we find that India was in the lead to find out the causes of monsoon after being devastated in 1866-67 by the great famines, while lakhs of people, thousands of people died in this continent. So then Director General of Meteorology, the great Walker, searched for the parameters, and that was the beginning of monsoon monitoring and forecasting. We could identify the Walker circulations, we could identify the southern oscillations, we could identify the various parameters which is governing the monsoon circulation over Indian and South Asian region. And by that way, also global community came up, and there was clear understanding gradually. And the day when we are discussing now, we have come up with a full-fledged, seamless forecasting system, starting with forecast for a few hours, called nowcast, up to the seasonal forecast for a period of 4 months. And we are talking about the decadal behavior and internal behavior, and also there are predictions by certain centers in US and UK. So I must congratulate all the scientists, young and old, for this development, which has enabled the society to minimize the losses of lives and properties, and also to optimize the utilization of weather and climate informations to gain in our economy. It needless to mention that there is a huge improvement in economy because of the improvement in monsoon forecasting, especially in India. The bad monsoon can affect up to 5% of the GDP. 70 to 90% of rainfall in India depends upon monsoon rainfall. Total rainfall of the country in a year is attributed to 70 to 90% by the monsoon. And hence, monsoon is considered as life. At the same time, monsoon is not limited only to agriculture. It also affects the water bodies. It affects the industries. It affects the community activities. It affects the individual activities. It affects all types of socioeconomic activities in the region. So therefore, all the festivals, all the activities in the society in India and abroad, you will find are tuned and organized with the activity of monsoon. The seasons are named after monsoon, the festivals are named after monsoons, and the religion also follows the monsoon. However, with all these developments, when we have got a seamless forecasting system and spatial and temporal scale, but there are still gaps and lack of understanding with respect to the oceanic processes, because this region, especially South Asia, Southeast Asia, and Middle East, if you consider, it is a data sparse region, being surrounded by the Great Himalayas to the north and the Bay of Bengal, Arabian Sea, and Indian Ocean to the east, west, and to the south. At the same time, many of the parameters governing the monsoon are well placed far away from this region, be in Atlantic, or be in South Indian Ocean, or be in Pacific, or somewhere else, or be in polar region. I think our secretary is here. So there are certain connectivity with the polar cryosphere and also the activity of monsoon. I hope the way in which this international workshop has been planned, though delayed by 1 year, will be helpful for each of us to identify the gap areas and will help us to have a better understanding through this conference, and it will help to plan for the future, better monitoring, forecasting, and warning services. At the same time, this international workshop on monsoon will help each of us to build the capacity. The knowledge transfer from the older generation to the younger generation, especially the young professionals, researchers, and scientists, will be a key output or outcome from this IWM-7. It is heartening to note that in spite of the threat due to COVID-19, there has been a large contribution. About 200 presentations, including invited oral and short oral, will be there during this 5 days workshop. I hope all of you will appreciate the difficulties in the presence of COVID-19 in organizing this online workshop. There will be certain difficulties because of this time zone management. Some people in somewhere will be facing difficulties. I beg pardon from all of you for not being able to arrange physically, though we tried our best for last 1 year to have this conference physically at New Delhi. Once again, I extend a warm welcome to all of you to this August workshop on International Workshop of Monsoon 7th edition, and I am hopeful it will be a great success with the presence of all the distinguished scientists and researchers in this program. So thank you very much.
Thank you very much, sir, for highlighting the ancient knowledge of monsoon and also the gap area, and that your talk or points will be very much discussed in the due course. Thank you very much, sir. Now, may I now request our two co-chairs of International Scientific Committee, Professor C.P. Cheng and then Dr. Ajit Tyagi, to give their remarks about the brief report of the IMPO activity and IWM-7. Over to you, sir. So we are sharing your PPT, Professor Chang, sir. Is it okay?
Yes, I'm sorry, I was muted. I'll try to share screen. If I fail, then maybe you can play my PowerPoint.
Okay. Please try.
So I'll screen window.
Our people can share it.
I have launched the share screen, but does it? I don't know whether it's not sharing.
It is sharing.
Oh, great. Okay. I will briefly review the current state and the future outlook of monsoon research. And I was given assigned this task last month in the launch event of the International Monsoon Project Office. Here, I'm going to make a very brief summary of this review. This is for spanning all timescales of monsoon research. And starting from the shortest time scale, the mesoscale, and then into synoptic scale. And there are the common features in different monsoon regions, including the mesoscale convective systems, topography, low-level jet diurnal cycle, and so forth. Those are all important topics for research, but there are special regional characteristics. Like Indian monsoon depression would be an important special system, and African monsoon, we have easterly waves, which could become which could induce tropical cyclone genesis. And then there are also winter monsoon in Southeast Asia, maritime continent, where cold surges can influence heavy rainfall. And these smaller scale and mesoscale weather systems are actually a focus of the working group for tropical meteorological research in the past. Here I'm going to show that, in fact, IWM, the one that we're holding now is IWM-7, is just one part of the IWM families. Starting in 2008, when the working group was become part of the World Weather Research Program, Prior to that was the Tropical Meteorological Research Program. Actually, there's more climate. But starting 2008, the focus is shifting to weather. So we have a series of workshops on monsoon heavy rainfall. That's MHR means. And as indicated, in fact, the third one was held in Delhi. And here is the abstract outline on the lower left. The last one was in Shenzhen. And this series of monsoon heavy rainfall workshop end up with the launch of a major field program. I will just mention, in addition, we have workshop on climate change that was 2 years ago. And the mesoscale field experiment is part of the WWRP RDP, Research and Development Project. And that's the Southern China Monsoon Experiment, which is a pretty comprehensive project that includes field observations, physical mechanism studies, and model studies, both in terms of interior dynamics, environmental conditions, and forecasts. They have a lot of good result and output, including the improving of QPF skills. And above the mesoscale and synoptics will be the intra-seasonal scale, where the predictability is mainly from MJO and its teleconnections. Global models used to have a lot of problems with simulating MJO, but there has been tremendous advancement so that models are now perform reasonably well, such as the GFD or SPEAR model that can now have good forecast skill and also good simulation of teleconnection for fast propagating and jumping MJO, but for the slower propagating and the standing MJO, they still have problem either in skill or teleconnection. And for future studies to solve those problems, which is mainly, there are two factors identified. One is the maritime continent barrier effect. The other one is the interaction with the stratospheric quasi-biennial oscillation. Above the intra-seasonal scale will be the seasonal scale or the annual cycles. And here it is well known that there exists a negative correlation between ENSO and the Indian monsoon rainfall. But I guess in the last 30, maybe 40 years, 50 years, it was realized that this negative correlation changes with time. So it declines sometime in late 20th century, then it recovers. Some recent studies shows that this may be due to the effect of sea surface temperature anomalies in the tropics. Professor Bin Wang and his team did some studies, and that shows this correlation actually exists not just over India monsoon, but over the entire Asia region. So they would call this Asian monsoon ENSO relationship, as shown in the upper left diagram here. The brown are the negative and the green are the positive, which depends on whether it's summer or winter monsoon. But they call this the relationship robust because the correlation exists in a lot of places and a lot of time. However, it's non-stationary because it's location varying, and in each location, say summer monsoon, it could be July, August, September having the highest correlation, or it could be May, June, July. It's winter season varying. It's also duration varying, whether the correlation exists for 2 months or 3 months, and so forth. And on the right-hand side, we have a 500-year, 544 years chart showing these fluctuations. And we can see that in the most recent maritime continent, India and northern China, the correlation all increases. And the highest correlation is maritime continent, just because seasonal forecast, seasonal predictability is mainly depending on ENSO, and ENSO has this displacement of the workers' circulation that affects maritime continent more. However, it turned out that in part of the American continent, that is the western part, as indicated here, the correlation is pretty bad, so that the climate is called COF, climate Outlook, COF, Climate Outlook Forum of Southeast Asia, was very unsuccessful in this region through several years. And in fact, in IWM-7, 6 in Singapore last time, some of us were interested in discussing that and came up with some ideas about the reason of that is not that ENSO has no effect in here, but ENSO has a lot of effect here. It has two effects. One is the displacement of Walker cell, but there's another one that influences low-level circulation, such that the two offset each other, ending up with very difficult prediction. So this is the reason I show this is because this is an example that global climate modelers, that's on the climate research, needs mesoscale weather researchers because the fact here is due to the mesoscale terrain. So there need to be the cooperation between WCRP and WWRP. Finally, on the longest time scale will be the climate change scale. And we had this workshop in Sahai late just before the pandemic hit. And there's a major report published in BAMS. And the summary of that is actually just show up in January issue of the printed version or digital version of BAMS just this year. So original paper 2021, the shorted version 2022. And there are a lot of results. I just simply touch on a few that both for past and also for future, there's a region. We all know that extreme rainfall would be more frequent and more intense, but there's significant regional and decadal variations. Also, this increase of extreme rainfall in some places are partly or all due to urbanization effect. And in the future, land monsoon rainfall also varies according to different regions like South Asia, East Asia, and Northern Africa monsoon. We expect increase of mean rainfall, but North American monsoon we expect decreasing, and Southern Hemisphere we expect little change. And for future challenges, model biases and parameterization, so forth. One point is that the global model does not seem to able to simulate extreme rainfall more than 1 meter per day. The most recent CMIT 6 projected land monsoon rainfall is 50% larger than the CMIT 5, so that is great news. However, the range of this change also is 50% larger, so that is not so great a news. The most important point, the most crucial challenge seems to be the prediction of internal modes of variability, namely internal mode versus radiative forcing. If this cannot be improved, then there remains to be a lot of uncertainties in the projections. Thank you. That's all my talk.
Thank you, Professor Chang, for highlighting the science part of the monsoon and how the challenges in the model prediction, and also feature what are the challenges is expected due to the climate change. Thank you very much, sir. Now, may I request Professor Tyagi, sir, to kindly share his view.
Dr. Ravichandran, Secretary, Ministry of Earth Sciences, Chairman, International Organizing Committee and National Organizing Committee. Dr. Mrityunjay Mahapatra, Director General of India Meteorological Department and PR of India with WMO. Estelle, Head of WWRP. Michael Sparrow, Head of WCRP. Professor C.P. Chang. Dr. Patnaik, esteemed delegates and distinguished scientists and participants. It's a great honor and privilege to present the planning of IWM-7. Professor Chang has covered the scientific advancements made through the series of IWMs conducted in last 35 years. And its transfer of technology from the research to the forecasters, which has been brought out. The scales which have been covered from mesoscale to climate and improvements in the forecast which have taken place is really commendable, and IWM has played a significant role in that. I'd also like to thank on behalf of WGTMR to the Government of India, Ministry of Earth Sciences, for extending wholehearted support and making this workshop a great success in terms of participation across the different time zones and across different domains. So this is really commendable despite of COVID, and the additional attraction of this particular series of the IWM of this year had been to organize a very successful international workshop, training workshop on S2S. And so these are the two very important activities which have been made possible despite of the challenges of the COVID. And this wouldn't have been possible without the support of Ministry of Earth Sciences, India Meteorological Department, Indian Institute of Tropical Meteorology, and IMPO. So thanks to the directors of these institutions and the head of IMPO, Dr. Kohli, Dr. Krishnan, Director IITM, and of course the Director General, Dr. Mahapatra, whose entire team as LOC has put the things together and managing this show with different time zones in excellent manner. Science has been covered, so let me go through the planning aspect of this workshop and how we are managing the different time zones, thanks to the, I think, planning done by the LOC. And so, Patnaik, would you put my presentation?
Yes. We are sharing, sir.
See, unlike routine scientific workshop seminars, the IWM was conceived with the specific objectives. The two key objectives were that it was to provide a platform for the researchers and forecasters. Next slide, please. To discuss recent advances and current issues covering all time scales, the mesoscale to the climate, that are relevant to the forecast of high impact weather in the monsoon regions around the world, focusing on the societal benefits. So this is the one of the key aspect of this. And the next one is to provide training. Next slide. Is a means of transfer of new science and technology to the national meteorological and hydrological services in the monsoon region through a training workshop that offers short courses on developing countries NMHS forecasters sponsored by the WMO. And I'm happy to say that despite of constraints, we have been to a great degree able to achieve this objective in IWM-7. IWM-7 as brought out by Professor C.P. Cheng is a major quadrennial workshop series of WMO under its WWRP. And now, since we are talking of seamless from weather to the climate, it works closely with the programs of WCRP and sister programs of WWRP, along with a host of the scientific agencies of the various national and meteorological hydrological services. So this is excellent scientific teamwork and the research of which positively helps the society in a great way. Next. As brought out by Professor Chang, it started, the first IWM was held in Bali, Indonesia in 1997. And thereafter, a series of these have been regularly being held. Second one in Delhi, almost the same dates, 23rd to 26th March of 2000, followed by Hangzhou, China in 2004. And next two international workshops also were held in China, followed by IWM-6 in Singapore, last held in 13 to 17 November 2017. As brought out, this IWM-7 was to be held from 8th to 12th March in 2021, but because of COVID, we wanted this to be a physical, and we requested for the postponement by 1 year, and we were quite hopeful that things will improve. But considering the conditions, we went for a hybrid. To the a virtual workshop, but as brought out by Dr. Mahapatra, there has been a very good response from all senior scientists to the younger scientists. We have invited speakers, thanks to the International Scientific Committee, with co-chairs being Professor CP. We have eminent 38 invited speakers covering all domains of the monsoon research. And we have researchers, younger researchers, who will be contribute oral presentations and the short presentations and the posters. So entire spectrum of scientists, from senior scientists to the young researchers, have been taken care of in this IWM-7. Next, please. So broad thematic areas being covered in this IWM-7 are the regional monsoons. We had 6 invited talks covered under this yesterday. Sub-seasonal to seasonal predictions, which is been the focus, and we'll have 2 technical sessions on this. Modeling of monsoon processes, climate change and monsoon, high impact monsoon weather, field experiments and observation campaigns. We had a presentation made in the morning session. Monsoon prediction for societal benefits and the new technologies. Next, please. So as mentioned, that with under the guidance of WGTMR co-chairs, Professor Wang Zhou and Yukari, in consultation with the DGM and the WWRP Secretariat, STEEL, and the ISC Chairman, Chris Davis, International Organizing Committee was constituted with Dr. M. Ravichandran, Secretary MOS, as the chair, and we had members representing all international scientific programs and key national meteorological and hydrological services. As brought out, that International Scientific Committee has been the backbone for organizing the scientific content of the workshop, and we were able to request, and we are thankful to all our invited speakers who have readily agreed, and despite of different time zones, and are making their presentations and have agreed to also contribute to the publication. Of course, this wouldn't have been happened without the support of the National Organizing Committee and the local organizing committee. And I would like to appreciate and convey thanks to each one of them. You will be surprised to know that even these web broadcasts are being done in-house. So this is really commendable achievement to manage such workshops in the different time zones so efficiently. So compliments and thanks to members of the local organizing committee. Of course, coordinator Dr. Patnaik is playing a very key role under the guidance of the Director General, and similarly, international training workshop was conducted under the guidance of Director IITM with IMPOs. So this is really an excellent teamwork which has made this happen. Thank you. Next. Okay, so we have 3 important activities under this IWM-7 as mentioned, the International Online S2S Training Workshop. See, typically earlier on physical training workshop used to be 3 days, half-day sessions in parallel sessions. But this time, because of virtual facilities, it was very elaborately planned with all S2S experts providing theoretical and practical sessions to 100-odd participants. So this was very good. I think I must say one of the success of IWM-7. And then the main workshop, which is now taking place. And of course, it will be followed by a special issue of Mosam, the quarterly journal, where all peer-reviewed papers will be published. Next. So this is what the training workshop is an important component. We organize it from 1st to 12th November 2021. More than 100 registrations of participants from National Meteorological and Hydrological Services and also from academic institutions around the world. A pre-workshop orientation course was done to familiarize with the data, tools, and other procedures of training workshops to make the training really effective. And of course, the IITM and IMQ played a key role in supporting this particular organization. Next. The organizing committee also has brought out abstract booklet. A copy of this will be available on IWM website, and it will be released by our Secretary and Chairman IOC in today's function. So this is another important part that has been achieved. Next. Okay, so the technical program already it's been shared with you. It covers 5 days starting from initially the workshop was supposed to be 23rd to 26th, but because of more number of invited speakers we were able to manage, so we planned advance it by 1 day, and we are having morning session morning 3 to 6 UTC and evening the current one 12:30 to 15:50. Total of 9 sessions will be there, 38 invited talks, and there are 9 technical sessions, 72 oral presentations, and 68 short oral cum posters presentations will be there. Okay, so these are the invited talks, and these are the oral presentations which will be covered. They are meticulously planned and being managed very well by the chairs. And this is the program overview, which is, I'm sure all of you must have gone through. So that is what as brought out by CP. All the earlier IWMs have been followed by a global monsoon system series of the booklets which have been widely received. And this time we are going to bring out a special issue of Quarterly Journal of Meteorology and Hydrology, that is MOSAM. It will have a peer-reviewed papers, and our co-chairs of the WGTMR has already requested invited speakers to submit the papers. So with this, once again, my thanks to the organizing support provided by the Ministry of Earth Sciences, the India Met Department, IITM, other institutions. Thank you. Jai Hind.
Yeah. Thank you, Professor Tyagi sir, for explain the details about the planning, etc. of the IWM-7 and how much work has gone behind this planning. Thank you very much, sir. So may I now request our head at WWRP division of WMO, Dr. Esther D. Coney, please.
Very much. Dear Dr. Muapatra, Professor Chang, Dr. Tyagi, and Dr. Patanik, and distinguished guests, I'm very honored to say a few words on behalf of the World Weather Research Program regarding monsoon research and its significance to WWRP. First of all, as the previous speakers, I would like to thank everybody who was involved in the organization of this workshop and the training workshop that was held last year. The International Monsoons Project Office, hosted by the Indian Institute of Tropical Meteorology, was recently established and launched, and in collaboration with the World Weather Research Program and the World Weather Climate Research Program. And this 7th International Monsoons Workshop is the very first activity officially under this new umbrella. The WWRP promotes international and interdisciplinary research for more accurate and reliable forecasts from minutes to seasons to enhance society's resilience. Monsoon systems that have a huge impact economically as well as socially and are accompanied by high impact weather events, which is both beneficial and hazardous, link meteorology, climatology, hydrology, agriculture, and water resource management on all timescales. And this information is much needed by the decision makers for early warnings and early actions. For the WWRP, the value cycle approach is extremely important. We need to cross the necessary bridges to our stakeholders by engaging them in the design of our projects, working with them during the projects, and co-evaluating the provided products with them. And this needs to feed back into redesign and adjustment to keep us moving forward. This is why a workshop like this one is really important, to establish this much needed dialogue between scientists and users of monsoon information. WWRP is busy developing a new implementation plan from 2024 to 2027, and research on monsoon systems will definitely be important beyond 2024 through the links with our Tropical Meteorological Research Working Group and related projects. Collaboration with the WCRP and the Monsoons Office in India is crucial to ensure the efficiency in our efforts to reach our common goals. This is a wonderful opportunity to discuss the developments in monsoon modeling, monsoon prediction on all timescales, new technologies and tools, results from field experiments, and the application of monsoon prediction capabilities to benefit society. We look forward to this event, formally inaugurated on World Med Day 2022, and the outcomes of this workshop. Thank you so much.
Thank you, Dr. Estelle, for highlighting how the WWRP is actively working for this monsoon and also the facilitating this collaboration and various research. Thank you very much. So may I now request our WCRP head from WMO, Dr. Michael Sparrow, to give his view. Over to you, sir.
Noon, or good evening, or good morning, depending on your time of day. First of all, I'd like to thank you, our kind hosts, for inviting me to say a few words on behalf of the World Climate Research Programme. As has already been shown so well by our esteemed colleagues today, the monsoons are global phenomena of particular importance to the Asia, Australian, African, and American regions. In order to fully understand and predict the monsoon systems, we need scientists from a variety of disciplines and different countries to work together with a common aim. As Estelle has already mentioned, this is why the World Climate Research Programme and the World Weather Research Programme launched the International Monsoons Project Office to consolidate monsoon research under both programmes. The IMPO is hosted and currently supported by the Indian Institute of Tropical Meteorology in Pune and is a global hub of monsoons research and will continue to expand and bring in more partners and becoming a real hub and focus for global monsoons research in the future. WCRP itself tackles monsoon research on a number of fronts. For example, a long-standing monsoons panel, co-led by our CLIVAR, which is Climate and Oceans, and GWEX, our Global Energy and Water Exchanges core projects, explores the global view of monsoons activities, enabling knowledge and best practice to be shared between the various monsoon regions. However, monsoons research cuts across many of our activities. For example, we coordinate a global monsoons model intercomparison project and an S2S, subseasonal to seasonal, sub-project on monsoons. Earlier this month, we also held a high-profile seminar on monsoon systems, tipping elements, irreversibility, and abrupt change, jointly with the Earth Commission and Future Earth's AIMS project. As WCRP moves ahead with implementing its new strategic plan and with a new structure in place, we will continue to focus on monsoons research, but working even more closely with our partners, both international and national. So I'd just like to finish by thanking you all, ladies and gentlemen, and would like to wish you a successful and scientifically interesting workshop. Thank you very much.
Thank you, Dr. Sparrow, for highlighting how this WCRP is working for the improvement of monsoon forecast to S2S. Many projects are there. So thank you very much. So now we have an agenda that, as you know, the Indian Met Society recognizes the scientists in the field of monsoon research. So now we have a role here that the Sir Gilbert Walker Award. So I will now just read the thing. Okay, so the Indian Meteorological Society is in its endeavor to recognize an outstanding and pioneering contribution in the field of meteorology and related area, has instituted the Sir Gilbert Walker Gold Medal. This award is to honor lifetime contributions towards discovery of new phenomena, understanding of the atmospheric and other processes, and developing meteorological services for societal benefits. Sir Gilbert Walker Gold Medal is awarded for the scientific contributions in the field of monsoon meteorology, including long-range forecasting of monsoon system, including tropical cyclone, and for overall contribution to the development of meteorology in India. Professor Dr. P.V. Joseph, born on 29 December 1932 in Kerala, the southern state of India, did his master's degree in physics in 1953 from the University of Madras. Joined the Indian department in 1957 at Colaba and Alibag Observatory, Bombay, where he did data collection and research in geomagnetism for 5 years. During 1962-63, he was trained in meteorology and weather prediction. For the subsequent 16 years, he worked in the Operational Weather Forecasting Center of IMD, particularly in aviation meteorology and cyclone warning. During 1980 to 1989, he was director of the WMO Regional Meteorological Training Center of IMD at Pune. In 1983, he obtained PhD degree in physics from University of Pune for research on monsoon variability. He has also contributed in the field of academics. Taking voluntary retirement from IMD in 1989, Dr. Joseph took up various assignments in India and USA as visiting scientist. Professor Joseph was also UGC visiting professor, emeritus professor of the Department of Atmospheric Science of the Cochin University of Science and Technology, where he did teaching of MSc and MTech course and research on the atmospheric and ocean system in collaboration with the faculty and PhD students. He has got many research and publications. He has done original research for more than 5 decades in tropical meteorology, monsoon, cyclone, and thunderstorm, climate change, and ocean atmospheric interaction. Professor Joseph discovered a low-level jet stream in monsoon and found that its axis had different latitudinal positions over India in the active and break phases of monsoon. His research work on instability in the ocean atmosphere system, a negative feedback that produces epochs like the 3 decades from 1961 to 1990 of frequent Indian monsoon drought and north-moving severe cyclones in the Bay of Bengal. He has published more than 70 research papers in reputed national and international journals. He has got many awards and recognitions because of his outstanding contribution. In recognition to his contribution, he has been awarded with many prestigious awards such as the Hariom Ashram Prerit Dr. Bikram Sarabhai Research Award in 1978. In 2012, he was the recipient of the Swadeshi Science Puraskaram and also of felicitation of the Foundation Day of India Met Department. Swadeshi Science Puraskaram National Award for Excellence in Atmospheric Science and Technology by Ministry of Earth Sciences in 2016. Professor Joseph was conferred upon the Lifetime Achievement Award of the Indian Meteorological Society in 2016. In recognition of his outstanding contribution to monsoon meteorology, the Indian Meteorological Society is privileged to confer upon Professor Dr. P.V. Joseph the Sir Gilbert Walker Gold Medal of the Indian Meteorological Society for the year 2019-2020 on this day of 23rd March 2022. IMS congratulates Professor P.V. Joseph for this professional accomplishment. Thank you. Professor Joseph, if he is online, then we can join. Yeah. Namaskar, sir.
Ask me to speak. So just hang on. Just speak something. No.
Namaste, Joseph, sir. Namaskar. Let me take a photograph.
Okay.
Okay, so
Heartiest congratulations, Dr. P.V. Joseph Saab, on behalf of all scientific community here in International Workshop for Monsoon, and also on behalf of Minister of Earth Sciences, India Meteorological Department, all sister organizations, and Indian Meteorological Society. Thank you very much for accepting the Sir Gilbert Walker Award. Thank you.
thank you, sir. Thank you very much, sir. So we will go to the next item. As
1 minute. The
Sir.
secretary wants to speak.
yeah, yes, sir. Please, sir.
No, just I convey the same thing. Congratulations, sir. That's
Thank you, sir. Thank you very much, sir. So now we'll move to the next item. As Dr. Tyagi sir was telling that, we have brought out a abstract books because more than around 200 abstracts were received, including invited speaker, oral, and this thing. So now may I request our secretary, MOS, Dr. Ravichandran sir, and also the chairman of NOC and ISO to kindly release the abstract book. Also, our DGM sir has a copy and I have also a copy. We can show this one. releasing the book. And our team can also play a small, just 1 minute video of this. Thank you. Thank you very much, sir, for releasing the abstract book. Yeah, so. Okay, so now may I request our Secretary MOS, Dr. M. Ravichandran, sir, and also he the chairman of NOC and International Organizing Committee to kindly address on this occasion. Thank you, sir.
Respected Professor Joseph Sir, Dr. Mahapatra, DGIMD and PR of India with the WMO, Dr. Michael Sparrow, Head WCRP Division of WMO, Dr. Koning, Head WWRP Division of WMO, Professor C.P. Chang and Dr. Ajit Tyagi, co-chairs of International Scientific Committee of IWM-7, Dr. Patnaik, coordinator of IWM-7, distinguished chairpersons of various sessions, invited speakers, participants, a very good afternoon, good morning, good evening, wherever you are. On behalf of the Ministry of Earth Sciences and Government of India, I welcome you all for the 7th WMO International Workshop on Monsoon. Greetings to all on this WMO World Meteorological Day. On this year theme, early warning, early action is more apt for this year's workshop. As you all know that how important is the monsoon for India. You know that we are blessed with the two monsoons, southwest and northeast. It is imperative that we need to predict the monsoon well in all time scales, especially short and medium range. Of course, for improving the forecast, we need to have a better observations. We need both in situ, like automatic weather stations or radio sonde, and also remote sensing like radars and satellites are very imperative. Of course, observations are required for both understanding and enhancing knowledge, and also to assimilate into the models for better initialization. For understanding, we need to have a high frequency observation for various parameters so that we can improve the model physics, parameters in scheme, and so on. Obviously, for better initialization, we need to have more observation for various types, and hence we need to augment more and more number of in-situ observations, surface as well as in the upper air for the better monsoon forecast and understanding. Of course, by increasing the observations, we can certainly improve our forecast in some degree. The next one to improve the forecast is to improve the model physics. And the other area to improve the forecast is we need to concentrate on the resolution of the model by augmenting more number of, maybe more required capacity of HPC. And also to reduce the uncertainty, we also need to have more number of more ensemble members. And also again, we need for more HPC for that. So obviously these observations, model physics, resolution, HPC, and all will contribute to improve the forecast. And the next important factor in the forecast of monsoon when we are talking about the important element is the ocean. So the same thing, observations, understanding, improvement in model and prediction, all these things holds good for the ocean side too. Of course, the ocean side, the mixed layer parameters is scheme is very important, especially in our regions, apart from resolution and other things. So the coupled model is essential for our forecast monsoon when we talk about monsoon forecast. If you see that if the forecast is more than a week or two, then always you know that ocean plays a very critical role. So without ocean, we cannot think of prediction beyond some 1 or 2 weeks. Of course, we need to have a teleconnections or local versus remote forcings, or somebody has pointed out the internal dynamics or the external forcings is another important factor that we need to explore for better predictability. Also, we need to put more effort on how the monsoon will change under global warming scenario, how as the time progresses, how the extreme rainfall and other things changes we need to understand. Slowly, I think we also need to incorporate the chemistry in the atmospheric model and also biogeochemistry in the ocean model, and then couple them in the physical model so that for better understanding and the forecast. So considering all these points, the Government of India has initiated the Monsoon Mission. Of course, there are already 2 phases have been over, and then both the phases, it has given very good understanding, knowledge has been provided by this Monsoon Mission, and also it has yielded some of the important component or improving the operational weather forecast. So due to this Monsoon Mission, India could also start the dynamical prediction system from the conventional statistical and other models. Now it is an evolving process and we need to improve year by year. Of course, for that, collaboration is the key for improving both the knowledge as well as operational utility. So both national as well as international collaboration is important. In that aspect, I think this workshop is very, very important. Of course, the knowledge, whatever we are gathering, that immediately we need to put it into the model for better predictability so that we can translate science to services for the benefit of society. That was the aim of this year's, of course, the WMO theme. Of course, this workshop definitely will pave way for many new knowledge as well as collaboration. And I thank you all for joining this workshop. And I am sure this workshop will be a grand success. Thank you, Ananda. Thank you.
Thank you very much, sir, for your encouraging words. And definitely this workshop will help much collaboration and also interaction among the different scientists from different parts of the globe will help to further strengthen the monsoon research. Thank you very much, sir. So now we have a video recorded message from our respected Secretary General of WMO. So I will request our team to kindly play this message.
Your Excellency, Dr. Ravichandran, Secretary, Ministry of Earth Sciences, Chairman, International Organizing Committee. Dr. Mohapatra, Director General of Meteorology, India Meteorological Department, and Permanent Representative of India with WMO. Professor Chang, Dr. Tyagi, Co-Chairs, International Scientific Committee. Dr. Patainak, Secretary, Indian Meteorology Society, and Coordinator of National Organizing Committee of this event. Dear colleagues, ladies and gentlemen, on behalf of the World Meteorological Organization and on my own behalf, I would like to express WMO's appreciation to address the 7th International Workshop on Monsoons. I would like to thank the Government of India, especially Ministry of Earth Sciences and the India Meteorological Department for hosting this online scientific event, which speaks of importance that India assigns to the vital climatic and environmental challenges that the international community faces today. Climate and environment-related challenges have long been everyday issues to India. It ranks 7th in the last United Nations Global Climate Risk Index, and in 2017 it was the second most affected country in terms of casualties related to extreme weather. India is affected by yearly monsoon season, typically lasting from June to early September. As you may recall, in 2019, the monsoon conditions continued a month longer than normal, with the rain surplus causing severe hardship to the country's population, with large death toll and multi-million people affected and displaced, and huge economic loss. I would like to congratulate the Indian government for taking several initiatives to tackle these climate and natural hazard issues. India is one of the few leaders in the implementation of the Paris Agreement on climate change. It has a national clean air program to combat air pollution, because you are facing one of the most difficult air quality problems worldwide. You are a founding member of the International Solar Alliance and has been notable targets related to solar power energy. The Indian government has initiated several flagship projects on environment, Clean India, Clean Gangstam, Smart Cities Mission, to name a few. It is also in the forefront in weather and climate research. Back to monsoons, true, too much rainfall can severely impact people's lives, but let us not forget that farmers, not only in India, but also in countries in monsoon regions, rely on the wet summer months to grow crops. The variations in the amount of monsoon rainfall have implications for agriculture and the economy. During the years when there is less rainfall than usual, crops either die in the fields or cannot be planted at all. We are all aware that countries with the monsoon climate are prone to floods and drought, both events hazardous to health. Each year, before the advent of the summer monsoon season, Indian hospitals prepare for possible high numbers of patients with cholera, dengue, chikungunya, malaria, eye and stomach infections. In winter, when clouds seldom give shade and the dry land surface can't cool by evaporation, heat waves are to watch for. In the sub-Saharan Africa, the number of meningitis cases drops with the coming of the first monsoon rains. Since this workshop is dedicated to advancing the prediction of monsoons with societal benefit, permit me to recall that the World Meteorological Organization have been fully supporting the monsoon workshop series for almost 2 decades now. In 1997, WMO organized the first international workshop on monsoons, spearheaded by WMO's monsoon panel in Bali, Indonesia. That was the start of a quadrennial workshop series, which is to provide a forum for researchers and forecasters to discuss recent advances and current issues involving monsoons as key features of Earth system phenomena, covering weather to climate timescales affecting large populations around the world. This workshop series has led to establishment of a number of international monsoon-related field campaigns through the years. Most notable of these field projects are the 2004 North American Monsoon Experiment, the 2006 African Monsoon Multidisciplinary Analysis, or AMMA for short, and the ongoing South China Monsoon Rainfall Experiment. It is also worth noting that the workshop series resulted in the publication of book series on monsoons currently used either as textbooks or valuable reference material on monsoon in several universities, weather services and schools of learning. The said book series documents the advances in the understanding and prediction of monsoon systems as discussed in the international workshop on monsoons and reviewed by experts from the global monsoon community. The fourth book in the series, the Multiscale Global Monsoon System, was published in 2020. Allow me to thank and congratulate the editors of the book, renowned monsoon experts, ably led by Professors Chang and Johnson. Furthermore, WMO's dedication on the advancement of monsoon science paved the way for the establishment of the International Monsoon Project Office, this year, hosted by the Indian Institute of Tropical Meteorology and Indian Meteorological Society. The IMPO is India's contribution to global monsoon research coordination under the auspices of WMO's World Weather Research Programme and the WMO IOC UNESCO ISC World Climate Research Programme. In addition to this, its principal focus on monsoons, I have noted that the 7th in the IWM series is also being held to promote partnerships in climate and environment to address the impact of monsoons as part of the societal challenges. It is indeed very important to convene multidisciplinary experts and scientists in tackling the monsoon issue to inform society, especially the political and economic policymakers, on the multitude of benefits to be derived from applied research in the areas of climate and environment, as well as on the issue of global climate change. Let me emphasize again the importance of the monsoon system in the circulation of the atmosphere. They play vital and diversified roles in the evolution of weather and climate systems. The global monsoon systems are defining feature of the Earth's climate and a forced response of the coupled climate system to the annual cycle of solar insolation. Variability of the monsoon systems can result in profound effects on climate and climate change in various regions of the globe. Monsoons are the very important systems that are closely associated with the genesis of tropical cyclones, which are the most devastating hazard with hydrometeorological nature. Onset of the monsoons will shift into tropical conversion zones, which is a hotbed to incubate embryos to develop into tropical cyclones. Majority of tropical cyclones are generated within the monsoon system's environment. This is especially so in Asia and the Pacific. Therefore, monsoon and tropical cyclone are just like two sides of the coin. Monsoon rainfall has profound economic and societal impacts for many parts of the Earth system and more than 2/3 of the global population. The variation in the amount of monsoon rain can indeed be disastrous when it goes to extremes, but let us not forget that the monsoon rains are also beneficial. Aside from being much needed in agricultural activities, the rains are harnessed as hydropower, filling up reservoirs and creating 25% of India's electricity. Therefore, increased knowledge, improved understanding and well-developed forecasting techniques of monsoon systems will be a vital contribution to well management of water resource, better mitigation and prevention of meteorological disasters, thus well-being of the vast population. Continued climate change and urbanization over the past century has already caused significant rise in the intensity and frequency of extreme rainfall events in all monsoon regions. That's with the high confidence. Observed changes in the monsoon system rainfall vary by region with significant decadal variations. According to IPCC's sixth assessment report, the Northern Hemisphere land monsoon rainfall as a whole declined from 1950 to 1980 and rebounded after the 80s due to competing influences of internal climate variability and radiative forcing from rising greenhouse gas concentrations and aerosol forcing. A decadal to multi-decadal internal variability over South Asia, East Asia and West Africa, increases in monsoon precipitation due to warming from greenhouse gas emissions were counteracted by decreases in monsoon precipitation due to cooling from human-caused aerosol emissions over the 20th century. Increases in West African monsoon precipitation since the 80s are partly due to growing influence of greenhouse gases and reductions in the cooling effect of human-caused aerosol emissions over Europe and North America. However, it remains a challenge to quantify their relative contributions. While there has been an overall improvement in the skill of monsoon forecasts in all timescales, right from short range to seasonal during recent years, the increasingly erratic monsoon weather patterns in the backdrop of climate change are making forecasts more unpredictable at local and regional scales. As a result, monsoon prediction at the regional scales is becoming more challenging and at the same time more imperative. Thus, strengthening of monsoon research to better support operations and services is a priority for many WMO members today. An accurate prediction of monsoon activities and associated rainfall is vital for the sustainable future of the planet and for the contribution of Sustainable Development Goals on disaster risk reduction, fresh water availability and supply, and food security, etc. WMO has established a dedicated hydrological coordinating panel to join all forces and sectors in international and regional organizations and institutions and academia to have concerted approach toward the Millennium Challenges and Sustainable Development Goals. As the specialized agency of the United Nations system, competent weather and climate and water, WMO, through the National Meteorological and Hydrological Services of its 187 member states and 6 member territories, ensured delivery of timely warnings and continuously offers reliable and authoritative support regardless of geographical and political boundaries. WMO has always been in the forefront in promoting both advances in sciences and technologies in the weather, climate, water and environment, etc., and application of those sciences and frontier technologies into operational services to societies. To meet evolving challenges in sciences and technologies and emerging requirement for better societies, WMO took the initiative in adopting Earth system approach to understanding and predicting weather, climate and water and environment related phenomena with impacts, including monsoons, and approved the WMO Unified Data Policy in last October, and for the international exchange of Earth system data during the extraordinary Congress. This Unified Data Policy covers Earth system data and products that will be exchanged among members under various categories. It will have a critical and long-term impacts in all dimensions of WMO communities and have laid a solid foundation for improved understanding and new development of monsoon science and prediction technologies. WMO is always behind you to provide support to meeting societal needs. In addition, I would like to share with you that WMO has developed a regional concept and approaches which enable regional structure and governance to most fit regional diversity and characteristics to meet evolving regional and national requirements. These regional concepts and approaches shall serve as reliable vehicles and platforms for WMO members to provide monsoon weather and climate forecasting services with unified international quality and standard. I hope you explore and fully utilize the regional structure and governance to enhance skills and competencies of members' national meteorological and hydrological services through a global network of monsoon forecasting. I am confident that your participation in this workshop, that your respective scientific communities will further highlight the importance of research in further enhancing the understanding of the monsoon system and lead to advancement in its prediction. The outcome of this workshop will enable your national meteorological and hydrological services to fulfill its fundamental mission to provide increasingly better services not only to your respective national communities in protecting life and property and in support of sustainable development, but the global community as a whole. I can assure you that WMO will be at your side throughout this vital humanitarian endeavor. I wish to thank once again Dr. Mohapatra for his kind invitation, to his entire team for the excellent coordination and arrangement in organizing this online monsoon workshop. To all participants of this workshop, your presence today speaks of your deep commitment to continue working together towards a safer world. May your collective endeavors in this workshop be fruitful. Thank you all for your kind attention.
Thank you, respected Secretary General, for the very wonderful speech, and also for highlighting how the WMO is actively working toward the trending the natural med services. Thank you very much. And also I must thank the SGOP Secretariat team for kindly arranging this one, Jiruna Kahana and Toyang Peng. So these two, I was in constant touch with them to get this message. Thank you very much. So now may I request our team to play the video message from the Honorable Minister of Earth Sciences, Dr. Jitendra Singh. We have got it, the message from them. So it is a video message because of busy schedule, he could not come due to the parliament session. So we'll now play the message given by the Honorable Minister of Earth Sciences, Dr. Jitendra Singh. Please.
Namaste. I welcome you all to this international workshop on monsoon being hosted by the India Meteorological Department, Ministry of Earth Sciences, Government of India. Ladies and gentlemen, you will be pleased to know that India is blessed with two monsoons. The southwest monsoon during the month from June to September and the northeast monsoon during October to December. Indian monsoons, the most prominent of the world's monsoon systems, which affect the people in every sphere of their life and have been there from ancient history to modern times. And these have also controlled their very everyday existence. India, ladies and gentlemen, has a long history of seasonal forecasting monsoon. After the Great Famine of India during 1876-78, under the British rule, and that large-scale crop failure that followed, there was a need for developing a tool for the seasonal monsoon rainfall forecast. Indeed, the Indian monsoon and the summer monsoon particularly was the target of the very first science-based seasonal forecast in the world, with an attempt by eminent Henry Francis Blandford, who also went on to become the first Director General of the India Meteorological Department, IMD, way back in 1884, which was mandated to forecast monsoon rainfall based on the extent and thickness of the Himalayan snows. Thus, the importance of monsoon prediction for socio-economic applications was recognized quite early, but understanding its variability across a wide range of time and space scales and providing reliable predictions remained a challenge even today, despite many scientific and technological advances. Recognizing the importance of improving monsoon prediction, the prediction capabilities in a country in a systematic and timely manner, the Government of India, under the leadership of Prime Minister Shri Narendra Modi, has launched an ambitious and a well-resourced research program on mission mode called the Monsoon Mission. Through this mission, ladies and gentlemen, India has augmented its capability of high-performance computing, the HPC, which is close to 10 petaflops now and is able to generate forecasts a very high resolution with 3-kilometer resolution using mesoscale model, 12-kilometer using global forecast system model, and about 38-kilometer using ocean atmosphere coupled model. The Monsoon Mission has therefore and thus helped in the significant improvement of monsoon forecasts in all the time scales, right from short range to seasonal. India is therefore proud of having one of the best monsoon prediction systems for generating real-time forecasts and warning all spatial scales, from a location-specific forecast to block, district, meteorological subdivisions, and homogeneous regions and temporal scales of a few hours, that is the nowcast, the 3 days, that is the short range forecast, the 4 to 7 days, that is the medium range forecast, and 1 to 4 weeks, that is the extended range forecast, and 1 month to a season, which is the long range forecast. The second phase of Monsoon Mission also focuses on sectoral applications and prediction of extreme weather. Substantial support is being provided by the Government of India, headed by Prime Minister Narendra Modi, under his guidance for monsoon research through the Monsoon Mission, which has successfully completed 2 phases and is about to embark on the 3rd phase from this year. Monsoon Mission was launched as a mission mode project by the Ministry of Earth Sciences, Government of India, with a vision to develop a state-of-the-art dynamical prediction system for the Indian monsoon rainfall. Under this program, the Ministry of Earth Sciences has made significant progress in prediction of seasonal forecast of monsoon rainfall and in minimizing model biases. Predictions of extreme events like cyclones and heavy rainfall have also improved significantly due to the continuous research efforts made by the Ministry of Earth Sciences. Probability of detection, which is an abbreviated form known as POD, for heavy rainfall warning during monsoon season is now 74% in the year 2021, which has improved by 51% in the year 2020 as compared to the year between 2002 to 2020. A recent survey by the National Council of Applied Economic Research, NCAER, showed that investments of nearly rupees 1,000 crore made by the Ministry of Earth Sciences in improving weather forecasting over the past 5 years have generated economic benefits worth rupees 50,000 crore for farmers, livestock and fishermen, which means a 50-fold gain from the investments alone. The 7th World Monsoon Workshop, or a WMO International Workshop, is hosted by India through the India Meteorological Department, Ministry of Earth Sciences, and is jointly coordinated by WWRP and WCRP. The International Workshop on Monsoon is a major quadrennial symposia workshop series under the World Weather Research of the World Meteorological Organization, namely the WMO. The 7th workshop in the series is being organized at New Delhi, India, jointly by India Meteorological Department of Earth Sciences, Government of India, and the WWRP, that is the Working Group on Tropical Meteorological Research, WGTMR, in cooperation with Monsoons Panel of the World Climate Research Program, WCRP, and the International Monsoon Project Office, IMPO, hosted by the Indian Institute of Tropical Meteorology, IITM, and Indian Meteorological Society, the IMS. And therefore, I am sure the IWM-7 will provide a forum for researchers and forecasters to discuss recent advances and current issues involving monsoons as key features of Earth system phenomena, covering weather to climate time scale, affecting large populations around the world. To conclude, I wish the 7th edition of International Workshop on Monsoon a great success, and I'm sure we'll come out with some very valuable conclusions and inferences. Thank you once again, ladies and gentlemen, and namaste.
Namaskar. Thank you very much, sir, for your nice inputs given to the participants for deliberation. Thank you very much, sir. So now it is the last and formal duty of giving a formal vote of thanks to all our distinguished guests. So may I now start? We are very much thankful to respected honorable ministers of Earth Sciences, the Government of India, Dr. Jitendra Singh ji, for spending their valuable time in spite of busy schedule of Parliament session going on. and recording the message, at least when we got it. So for the thing. So thank you very much, sir. Now, respected SG, Secretary General, WMO, also, we are very thankful to you and also entire team of the WMO Secretariat for kindly spending valuable time for giving the message, and also the supporting IMD India for hosting this event. Thank you very much, sir. Now, our Secretary, Dr. Ravichandran sir, M. Ravichandran sir, NSC ISC Chairman, and he also contribution in supporting from the beginning, and also our previous Secretary for this conceptualizing this monsoon workshop and valuable guidance from time to time. Thank you very much, sir, for your guidance for conducting this workshop. Now, our sincere thanks to the Dr. M. Mahapatra, sir, Director General of Meteorology. Under his guidance, we could able to do at a local level the minute things, and also the all arrangements are done in IMD because of his valuable support. And thank you very much, sir, for your guidance. Then also we are thankful to our international committee chairs, Professor C.P. Chang and Dr. Ajit Tyagi, sir. For time to time, we are holding deliberation from last many months for this one, and their constant support guidance was helpful to LOC for organizing this event and also planning this timetable. And so we are very much thankful to all the co-chairs of ISC. In addition, we have also the having frequent meeting, Dr. Yukari and Takayabu and Ju Wang, co-chairs WMO, WGTMR. That is also, we are there. So we are thankful to both of them because we are for the planning of all this workshop. And also we are bringing out a special issue of Monsoon, so that also we are planning together. And we are in this regard, we are thankful to both of them. Then our special thanks to WWRP head and WCRP head, Dr. Estelle and Dr. Michael Sparrow, respectively, for spending the variable time and coming here and explaining how the WCRP and WWRP are working to enhancing the monsoon forecast. There are many things, and yes, I should must thank the IITM director, Dr. R. Krishnan, the executive director of IMPO, Dr. Rupa Kumar, because they conducted the training workshop that is actually happened simultaneously, it's a side-by-side event, but we could not hold it. So it was a November last year, it was arranged. So thanks to IITM and the IMPO, Dr. Susmita Joseph also part of that. So that entire training team, it was a very successful team, training as part of this IMW workshop. So that training was also very successfully conducted. And my team here in local levels, yes, it is a technical team also. They gave me constant support and under the guidance of DGM sir. So just to name few, Dr. Arul Alan, Mr. Bushier, and all our international division, Dr. Giri, our admin, Dr. Soni, and the getting MHA, MEA clearance, and also all our staff here. I just, because of lack of time, I'm not taking any name, but yes, we are thankful to each and everybody, those who have contributed for making this event a success. Finally, I must thank all the invited speakers and contributors and also the participants for in spite of their timing problem constraint. So I must thank all of them for a valuable contribution and also giving the talk. So that is also very scientifically, it will be very useful. This proceeding will be available for everybody in the later time in YouTube and other video. So thanks to everybody. Finally, we are thanking all of you for the attendance. Thank you very much. Okay, so we will just thanks once again. And since we have just past the time, and there will be no break, and we will go for the one invited session directly followed by this one. So just we can have another 3-4 minutes just break, and we will come back after another 5 minutes, let us say. Local it is 7:40. We can come back. 5 minutes break.
टैक्स साहब
ठीक दिख रहा है, शेयरिंग हो रहा है ठीक से।
हो रहा है ना?
हम्म।
ओके ओके
हाँ हो गया, अनशेयर कर दे, ठीक है।
किधर चला गया यार?
आप स्टॉप शेयरिंग कर दीजिए।
स्टॉप हुआ कि नहीं?
व्यूइंग सहाई एप्लीकेशन कोई दिखा रहा है, शायद हुआ है लग रहा है। हाँ हो गया, अभी हो गया।
हो गया? So I will try to do from my side. If there will be any problem, then I can ask.
Yes sir, no problem. So should we start now?
Hello.
Yeah, hello.
Yes, Yali, I'm trying to share my presentation. Can you see? Can you see my file on your screen?
Yeah, we will be sharing from our side, no? Or you will share?
Okay. So should we start now?
Yeah. So we can start now. So now,
Okay.
yeah. So first, yeah, we will start now this session, and now I will invite Dr. Yali Luo to kindly share the session. And Dr. Yali Luo is currently a senior scientist at the State Key Laboratory of Severe Weather, Chinese Academy of Meteorological Sciences, China. Her research mainly focuses on convective storms and extreme weather. She received her PhD degree at University of Utah, United States in 2003. She was the chief scientist of the Southern China Monsoon Rainfall Experiment, SCMREX, a WMO-WRP research or development project of 2014 to 2020. Over to you, Yali.
Okay, thanks for the introduction. This session includes 4 talks. The first one will be given by myself, so I'm trying to share my screen. Can you see?
Yes, it's fine.
Okay, the title of my talk is Convective and Microphysical Characteristics of Extreme Precipitation, reviewed by multi-source observations over the Pearl River Delta at Monsoon Coast. My talk consists of 4 parts. I'll start from background.
Sorry for interrupting. Actually, your slides are not moving.
You cannot see my screen?
Now it is title only. So I suggest you to unshare and share the screen. Instead of presentation, please share the screen.
Oh, okay.
Yeah. You unshare. It is slightly not moving. So you unshare, then just share the screen.
Okay.
Yeah, it is the screen at the leftmost panel.
Okay, I see.
Okay. Yes. Okay.
Okay. Okay. Yeah, extreme precipitation has caused the largest economic losses and deaths on the Earth. And increased trends have been found over many regions over the world at hourly, daily, and longer temporal scales. Such increase in extreme precipitation is associated with climate warming and also rapid urbanization. While the thermodynamic contribution to the increase in trends has been well understood, dynamic contribution remains unclear, especially the mesoscale and convective processes. Regarding the overlapping fraction between extreme precipitation and extreme convection, satellite-based observations indicate large, substantial regional variations. Some studies have found less than 10% of overlapping fraction on the mostly overland, including monsoon coast. Well, another recent study has found about 30 to 40% at the monsoon coast and over 60% over many land regions. Moreover, the satellite-based previous studies have mainly focused on deep convection over the monsoon regions and paid less attention to the shallow convective systems with weaker convection. Therefore, the microphysical characteristics of extreme precipitation in the monsoon regions are not well known. Recent studies have found that extreme heavy short-term rain rate sometimes is accompanied by low-level mass gamma scale rotation, which means has diameters of several to a dozen kilometers. Theoretically, such low-level rotation can enhance the upward motion in the low levels through the nonlinear dynamic acceleration, which can enhance the warm rain processes and increase the surface rainfall. We have also found the maximum hourly rain rate up to 290 millimeter per hour, influencing the capital city Guangzhou on the coast of South China, was produced by a weaker convective system accompanied by a massive gamma scale vortex. However, the statistical relation between extreme short-term rain rate and rotation at monsoon coasts is unknown. With that background, we aim to document the convective and microphysical characteristics of extreme precipitation on a typical monsoon coast, South China. Here it is the Pearl River Delta, including the convective intensity, liquid and mixed phase microflux, and also mass gamma scale rotation. We mainly use the dual polarization radar located at the capital city Guangzhou, combined with numerous two-dimensional video hygrometers and the low-frequency E-field detection array and the densely distributed automatic weather stations at minute temporal resolution. We have used a series of state-of-the-art methods for the quantitative precipitation estimate, for the ice water content and the liquid water content retrieval, and for the rain drop size distribution retrieval, as well as for the atmospheric calculation to estimate the presence and the intensity of rotation inside the convective systems. We define our extreme precipitation feature, EPF, as a contiguous area like this of strong radar reflectivity, which is at least 3 square kilometer and contains at least 0.5 square kilometer of extreme rain rate. The threshold value of extreme rain rate is 140 millimeter per hour. This definition is an event-based method, which is similar to the definition used to define the precipitation feature in the CHIM dataset developed at the University of Utah. Here are two examples of the EPF. One is vertically extended up to beyond 15 kilometer, and the other is hardly beyond the 6 kilometer. And we found totally more than 9,000 EPFs in 2 warm seasons. And they are produced by convective systems with convective intensity covering a wide range. About 17% EPFs have the maximum height of 40 dBz echo top, reaching up to 9 kilometer. They are defined as intense convection because large precipitation particles such as graupels and even hails are lifted up to beyond the -22-degree level by strong updrafts. And on the other hand, about 34% EPFs have a maximum height of 40 dB the ectop below 6 km. They are named weak convection because their convective objects are not strong enough to support graupels beyond -4 degree. And about a half of the EPF are named moderate convection with graupels between 6 and 9 km. And the independent observations of the lightning flash strongly support the estimation of convective intensity based on the radar observations. Below the freezing level, we can see the ZDR and the KDP increase toward the ground, which means both the size and the mass of raindrop decreases when the raindrops are falling toward the ground and due to the warm rain processes. And such increase rate of the KDP is even larger in the with weaker convection, while in the intense convection, the KDP below 4 km remain nearly constant. And meanwhile, the ratio of liquid water path to ice water path increases from 2.6 in the intense convection to 4.8 in the weak convection. All these results collectively suggest that overall, the extreme rain production is contributed significantly by warm rain processes, especially with weak convection. Meanwhile, about 2/3 EPFs are also contributed by melting of aggregates and graupels formed by aggregation and riming aloft. If we look at the raindrop distribution, we found a very high concentration regardless of convective intensity. The raindrop concentration is about 1 order of magnitude larger than the continental regime. And the raindrop size are mostly moderate between the maritime region and the continental region. The liquid phase microfluidic processes is dominated by coalescence. And it's beyond 90% with weak convection. The size sorting and breakup associated with larger raindrops and also the evaporation are all quite limited, especially with weaker convection. We also examined the seasonal variations of EPF characteristics by grouping the EPFs into 4 periods, namely the pre-monsoon onset period, active monsoon period, post-monsoon period, and the days with tropical cyclones influencing South China coast. It is found that the EPFs during the active monsoon period and the post-monsoon period vertically extend to higher latitudes than the other 2 periods, and with much more flashes. So this means more intense convection and associated with the extreme rainfall production during the active monsoon period and the post-monsoon periods. And also during the tropical cyclone days, the extreme rainfall was produced by even more active accretion and auto-conversion of liquid drops, with a higher concentration of smaller raindrops in thicker warm cloud layers. We found 265 records of hourly rain rate larger than 75 millimeter per hour observed by the rain gauges over the Pearl River Delta, and about 70% of those EXHP records are accompanied by the massive gamma scale rotation, and all the most extreme winds beyond 120 millimeters per hour are all with rotation. However, if we compare the mean rain rate between the two groups with rotation and without rotation respectively, the means are almost the same. And we could not find any correlation between extreme out precipitation and the atmospheric shear. So this is likely because of the wake rotation associated with this extreme rainfall production. The atmospheric shear is quite smaller compared to the tornado producing mesocyclones in eastern United States. And these features are closely associated with the environmental conditions under which the extreme rainfall was produced. The environmental atmosphere was very humid with precipitable water beyond about 64 to 66 millimeter by average, and the Cape was moderate to high, mostly about 1,000 to 2,000 joule per kilogram. This means that the thermodynamic conditions are very favorable for the warm rain processes. On the other hand, the low-level vertical wind shear and the storm relative facility are all quite small. They are smaller than their counterparts in the United States, which means the environmental conditions are not favorable for formation of strong rotation inside the convective storms. So these results indicate that the wake rotation likely results from strong condensation-induced latent heat release. To conclude, we have investigated the convective and microphysical characteristics of extreme precipitation at a typical monsoon coast, South China, based on the long-term observations with minute and sub-kilometer resolutions. The major findings are as follows. First of all, we found that the extreme rain production is associated with a wide range of convective intensity. Only 70% is intense convection, and about 34% is a weak convection, and another half is about moderate convection. Overall, extreme rain rate is contributed significantly by warm rain processes, especially with weaker convection. The range of set distribution features a high concentration and mostly moderate size of raindrops. Coalescence dominates the liquid phase microphysical processes. On the tropical cyclone days, even more active accretion and auto-conversion of liquid drops with a higher concentration of smaller raindrops in thicker warm cloud layers. About 70% extreme hourly precipitation larger than 75 millimeters per hour was with massive gamma scale rotation, but there is no correlation between their intensity. The rotation is generally weak and likely results from strong condensation-induced latent heat release in environments with high precipitate water, moderate to high Cape, and low vertical wind shear. Thank you very much for your attention. So any questions?
I have a question. And
sure. Sure.
Okay, I think can you is the terrain over the southern China play any role to enhance the echo top of the convection system?
The terrain at the South China coast, they play a very important role in the convective initiation and also the development of heavy rainfall storms. But it's not very clear whether they can make the echo top higher. I'm not sure. It's very important for convective initiation because it can produce the lifting impact on the warm and moisture air from the South China Sea.
Okay, thank you.
Thank you.
I have a question. This is Mohan from NCM. Hello.
Okay. Hi.
Yeah. Hi. Nice talk. I had a question regarding this 2D video distometer measurements that you have taken for your study. The instrument is very sensitive for the large humidities and higher wind speeds. So how do you, I mean, what kind of care did you take while measuring those for these measurements? Did you done any calibration or?
Oh, the 2DVD, yeah.
Yep.
2DVD, you know, Xiantong Liu, my collaborator, he is expert on 2DVD. So he processed all the measurements.
Okay. Because most of the DSD relationships with the 2D distometer, the terminal velocities of the rainfall is highly affected for the wind. So I was just wondering what care did you take?
Yeah,
that's okay.
Actually, the 2DVD measurements are mainly used to establish some relationship between you know, about the the range of size distribution parameters, and then that is used in our retrieval of ice water content and liquid water content. Okay. Yeah, it's mainly used here. Yeah.
Okay. Thank you. Thank you.
Okay.
Can I ask you a question? This is Madhu from IITM. Can I ask the question?
Sure, please go ahead.
Yeah, it's a very good presentation. I really enjoyed it. So I would like to ask that you importantly mentioned about the mixed phase clouds, which is between 6 to 9 is contributing much, like more than 40% as compared to the other one, and the mesoscale
I'm
rotations
sorry, I
is
cannot
explaining.
hear you very clearly. I'm sorry.
One is the mixed phase clouds in between 6 to 9
phase clouds.
kilometers altitude. Yeah, 6 to 9 kilometer altitude is much contributing, like more than 40%. So that is your blue things, and another one is the meso rotation explains 70%. I just want to ask that whether the various cloud regions like warm clouds, mixed phase, and ice clouds, whether they are merging can
Yeah, I'm
helping
sorry,
us
I
to be
cannot
more.
hear you very clearly. I'm very sorry. I'm very sorry. I cannot hear you very clearly. I beg your pardon? Can you hear me?
Yes, I will write a question personally to you. So because my audio may be an issue.
Okay, if no more questions, we may go ahead. So let me stop my sharing. Now let's welcome the next speaker, Dr. A.K. Sahai from India.
Thank you, Yali.
Yes, I can hear you and I can see you.
Okay. So my topic will be on extended range prediction.
Please use full screen.
Pardon?
Full screen. Okay, go ahead.
Okay. So I'm not giving details of the skills and other things. But one thing I will mention here, that monsoon intra-seasonal variability, which is the main thing which we are predicting on extended range 2 to 4 weeks. This is modulated by synoptic, interannual, and decadal variability. So all variabilities are mixed, and we have to predict only intra-seasonal variability. On top of this, this climate change is also there, which is modulating monsoon intra-seasonal oscillations, and therefore their prediction is a great challenge. And but one thing is there, that despite several uncertainties in the representation of climate process, the current generation models represent the hydrological cycle, and particularly the mean monsoon is predictable up to a certain extent. So after the launch of Monsoon Mission by Government of India, National Monsoon Mission, which our Honorable Secretary has mentioned, we have started working on extended range since 2011 using NCEP CFS model, and then we did various experiments and other things. And this prediction is playing an important role in improving the agriculture and water management, health, disaster, and other sectors. I will come to that. So extended and prediction system at present is operational at IMD, which was developed in collaboration with NCEP at Indian Institute of Tropical Meteorology. And I'm not going to detail on this, but this system is giving for monsoon active and break conditions, and monsoon intra-seasonal oscillation, MGO, also heat wave, cold wave, and northeast monsoon, cyclogenesis, and it has sectorial applications in agriculture, hydrology, energy, health sector, and urban planning, and so on. So it has a reasonable skill in predicting the extreme rainfall events, genesis, and track of tropical cyclones, heat wave, cold wave. So I'm not going on detail on these skills. Here there are two websites. One is at IATM, another at IMD. You can see these extended products. Now, what products are there? One is the deterministic categorical forecast of below normal, near normal, above normal for the weekly mean from first week to 4 week. So this is the latest forecast. Latest forecast will be issued now tomorrow on based on today's initial conditions. So this is last week forecast. So here you will get categories of below normal. And so there are altogether 16 members are there in this. So based on 16 members, one deterministic member mean MME is then. And then we also give probabilistic forecast based on each. So in some places, even you will see that there is a extreme, above normal predicted is there, but you will find that this is actually near normal or so, if you see the percentage. So sometimes it happens that one member will be very high, and therefore it will make it above normal, but most of the members are along the normal side, so it will be the normal in the probabilistic forecast. So we have, when we are using this, we have to see both this deterministic and probabilistic forecast. We also produce minimum temperature and maximum temperature, and here I am just giving anomalies for 4 week, minimum temperature left side and maximum temperature right side. And then, so these are actually we are generating based on maximum temperature, heat wave, and severe heat wave for 4 week. And also we in different regions, homogeneous regions, central India, north and west, and northeast India and south peninsular India, we are giving how it is different than the climatology. So you will see that in higher side of temperature, in central India, it is giving that in the first, there may be in the total, you can say in the 15 day, it will be slightly cooler than climatology, but North and West India and Northeast India, they are warmer than climatology. So this type of products, also we are giving what will be the 4 week probability of cyclogenesis and evolution of cyclones. We are also giving what will be the how the MGO will be moving in the different phases, and how the associated OLR in different weeks are there, and also daily evolution of this MJO and associated OLR anomalies, and also we are giving this one from wheat sector to wheat sector it is going, and when it is more than one and when it is very high. So all these things about MJO we are giving. Now these products, so we are also collaborating with various IITs, universities, and central agencies to generate and co-produce various products. So one product is by suppose this is for agriculture. So this is given by Central Research Institute of Dryland Agriculture, and you will see that they are giving using every week. They will give what is the minimum temperature, maximum temperature, and for each state and each district, they will give some what is the condition, how you have to go, and what are the advisories. So due to decrease in temperature, it is advised to irrigate the banana and so on. This type of products are being generated. Then there is a hydrological from IIT Gandhinagar. We are generating this products. So here you will see weekly soil moisture. What is so various products are being generated. One example is this soil moisture and other things using this forecast. Then
Any problem?
Sahai sir, can you hear me?
yeah, I can hear. Can you hear me?
Yes, sir. Please go ahead. I have put the presentation.
Okay, fine. So next slide, please. Yeah, so now I will show some applications on heat wave products. Next. Why we are seeing the heat wave? Because if you see here from 1951 to 2017, every decade, and now it is a large part of East India and also Southeast India and southern country also is affected by heat waves. Next. And these heat waves, actually, when there is a drought in the previous year or deficient monsoon, and this year is a heat wave, there is 60% chance of heat wave this year. Hello? You can hear me? Hello? Can you hear me? Okay. So then there is a so that affects agriculture and drinking water. Also, if the temperature is very high, this is one news clipping in of 6 June 2017, that power demand in Delhi crossed 6,500 megawatt. So temperature and heat wave forecast is very, very important. Next. Next slide.
Okay.
Yeah.
We can see the screen.
Yeah, I can see.
Okay, please continue.
Yeah. So this is what we are generating. This I am giving one example on 16th May 2018. Next. So yeah. So top 3 panels are hot days, heat wave, and severe heat waves. How it was observed from 18th May to 1st June. And there are 3 panels below forecast from 2nd May, 9th May, and 16th May. You can see that even from 2nd May also we were able to predict hot days and heat waves, and some part of severe heat wave also. Next. Same thing we can see here. This is the observed 4-week mean for heat wave and severe heat wave, and this is the prediction of heat wave and severe heat wave. So more or less we are able to predict. Next. And then there is the effect of humidity. Just click on this slide. Yeah, so you will see that, okay, yeah, these regions actually where humidity is anomaly is positive, and that will be more worsened with the effect of Tmax. Next. But this product's generation has no meaning if it is not being utilized, and therefore, if you see in 2015, which was more than 2,500 deaths were there in India, and then the National Disaster Management Authority came into picture that no, this is a type of national disaster, natural disaster. So let us make some efforts. So they, with collaboration with the India Meteorological Department and various organizations, based on the forecast, they in 2016, though 2016 is the warmest year since 1901, but you see that from 2015 to 2016, this has drastically decreased, and then 17, 18 also. 17 was third warmest, and 21 only 4 deaths, and so you can see that significant decrease in deaths due to heat waves occurred. So this is only possible if the forecast advisories are being utilized by the decision makers and disaster managers and other state. Next. Yeah, then I will come to hydrological products. This is one product in 2018. You can see this is from left hand side is the forecast from 28th July to 8th August, and the second one how it was observed, and this is for drought monitoring SPI index. And based on this, if you see, there are almost same category and one category there are 70, more than 70%, 73.4% were there within one category. So this forecast of SPI for monitoring drought is very useful. Next. This is also verified by IIT Gandhinagar products that these are the observations up to 7 to 45 leads, and these are the IITM-IMD products generated by our climate variables for runoff and root zone soil moisture. It is skillful. Next. It is also seen for 5 river basin in Maharashtra in this region, that how you see this line is observed for precipitation and mean temperature, but runoff and soil moisture and stream flow. So these are 7-day, 14-day, and 3-week and 4-week forecast. You can see that it is very reasonably capturing the observation. So these products are very useful for utilization in hydrological sector. Next. These products are also being utilized in agriculture sector by, and as I have told you, National Advisory Bulletin by CRIDA. Next. They are taking this observed realized rainfall, and then next the 2 weeks predicted rainfall, and then again they give these advisories for different countries, different states. Like this is for Maharashtra, rainfall received during this October, major meteorological subdivision in Vidarbha and Marathwada, how they are giving. Next. They have also given for Odisha, Assam, other states. Next. Now I will give one example and I will compare how it is important for decision makers and for utilizers, or even for the disaster managers to utilize this forecast. This is, I am giving one example of 6 June initial condition forecast for 15 to 20. This is 2nd week forecast. This is 3rd week forecast. Next. And this is a particular region, Vidarbha. You see that they got very good rainfall up to 8 June. So total up to 10 June, they were, even though there was sufficient realized rainfall during the first 10 days of June, and this was fulfilling the criteria of sowing. But this is the 5-day short range forecast, and based on this last slide 2 extended range forecast, it was told that no, there will be not much rainfall for the next 10-15 days. So don't go for sowing unless there is sufficient rain. And similar advisories were used or issued in 2017. This is talking, but that was not utilized by state government authorities and agricultural authorities in that sense, and huge loss was there for in the Vidarbha and Marathwada region. But this year, when we gave the forecast, a lot of emphasis was there, and even the Chief Minister of Maharashtra, he came onto TV and radio and he advised farmers to follow the advisory. And then what happened? Only 8% of area was sown by 25th June. But in the 2017, 45% area was already sown for that. So they have not utilized the advisory in 2017. So as the forecast was correct and sowing was not undertaken in 2018, there was no report of crop loss, but there was.
I'm sorry, Dr. Sahai.
Yeah.
The time is over.
Yeah. Just.
I'm sorry.
Next. Next. This is also being health products, I have told you. Next. So we are giving for dengue and malaria. This is one example. Next. Next. We are giving deterministic and probabilistic forecast both. Next. Next. So here, before this. Okay, you are not having other. Okay, fine. So then since when we compared this forecast which we are using with the real data, we found that only temperature will not be sufficient to give the malaria and dengue things. So we did some research and we found that rainfall and other parameters are also very important, and then we developed another thing. Next. So now I will come to the summary that these forecasts are very useful. But for extreme events, there are spatio-temporal errors, and therefore we are going for the next version for using multi-physics, multi-member, and vertical resolution also we are increasing, and we are also using AI/ML. But the most important thing is for better services in various sectors, a strong collaboration between weather, climate scientists, and stakeholders. And co-production is very much needed. And then for the disaster managers and other managers, they have to utilize this. But unless there is error in a spatio-temporal is reducing, it is very difficult for them also to utilize. Thank you very much.
Okay, thank you, Dr. Sahai. Because of the time limit, let's move on to the next speaker. Thanks a lot. Yeah, nice presentation.
Issue with my presentation, no problem. Okay, thank you.
Yeah, the next invited talk will be given by Professor Ming-Jen Yang. Yeah, Professor Ming-Jen Yang received his PhD. Oh. So Professor Yang, please sharing your screen.
Okay. Let me try again.
Sure.
Can you see my screen now?
Not yet.
Can you see my screen now?
Not yet.
Some technical problem.
Please try again.
Okay.
Sir, do you want us to share?
Maybe you share for me. I have some technical problem.
Good.
Can you see the screen now?
Yeah, very good.
Okay,
Can you
thank you.
continue? Okay. Yeah.
Okay, good evening, everyone. The title of my talk is The Evolution of the Water Budget and the Precipitation Efficiency of the Mesoscale Climatic System associated with the southwesterly monsoon flow over the South China Sea. Okay, next. I think the motivation of the study is because there are always abundant moisture transport associated with the monsoon flow, and that moisture frequently produces heavy rainfall and severe flooding over the East Asia area. Therefore, an improved understanding and the prediction of the moisture transfer is necessary. So two scientific questions we would like to study in this research. First is how does the moisture transfer along the southwesterly monsoon flow across the South China Sea will change with the increase or decrease of the low-level moisture and the wind speed. The second is that whether the wind convergence or the water vapor advection play a more important role in the change of the vapor flux convergence associated with the monsoon flow. Next. So we use the Wolf model to conduct a modeling study, and the version of the Wolf model is 3.9. We have 90 hours simulation for the August 25th to August 28 in 2015. And we use a triply nasty grid. The outer grid has a grid size of 27 kilometers, and the middle domain has the grid size of 9 kilometers, and the inner domain have the grid size of 3 kilometers. For boundary condition and initial condition, we use the ECNWF ERA interim model. And for the microfluidic scheme, we use the Morrison scheme, and we only use the cumulus scheme on the outer domain of the 27 kilometer grid. And in addition to the control simulation, we also conduct 4 sensitivity study. So basically, for the low level from surface to 700 millibar, we increase the relative humidity either 10% by the wet 10 experiment, or decrease the relative humidity by 10% as the dry 10 experiment. And we also change the wind speed by increase the 10%, called the faster 10 experiment, or decrease the wind speed by the S10, slow 10 speed. So 4 sensitivity study is conducted. Next, please. So the panel, the upper left panel shows the 3-hour accumulated rainfall from the CMOF global analysis, and the lower panel shows the corresponding WRF control simulation. So basically, we can see associated with the monsoon flow, there are the strong precipitation, and that's well captured by the WRF simulation. Next. And this one shows the comparison of the integrated water vapor, and our upper panel shows the ERA interim large scale analysis, and lower panel shows the corresponding result from the WRF control simulation. So basically, we can see the WRF can capture the movement of the moisture associated with the monsoon flow in the 3 days. And we can see in these 3 days, the moisture in the monsoon flow is changing to the east of Taiwan to the west of Taiwan. Next. And this one shows the result for the IVT, integrated water vapor transfer, as defined in this equation. And the middle panel shows the control simulation result. And the upper left is the wet 10 by increasing 10% relative humidity. And we can say by increasing the relative humidity, the moisture also increase. And then on the dry 10 experiment, because of the reduction of the relative humidity, the IVT is also decreased. On the other hand, if we look at the fast 10 experiment or a slow 10 experiment, the IVT result is similar to the control simulation. So basically, we can see that for the integrated moisture transport, it is more sensitive to the moisture change, but less sensitive to the wind speed change. Next. So the upper panel shows the 84-hour evolution of the IWM-7 integrated moisture transport and the integrated vapor transport associated with the monsoon flow. And the lower panel shows the relative change of the area average IWM-7 and the IVT from the sensitivity experiment relative to the control. So basically, we can see that by increasing or decreasing the relative humidity, the integrated moisture transport and the integrated vapor transport have a bigger variation from 10 to 30%. On the other hand, by changing the wind speed 10% or decrease 10%, there's only very small change on the integrated moisture transport and the integrated vapor transport. Next. So the upper panel shows the system total evolution of the accumulated rainfall along the monsoon flow. So again, we can see that moisture change can have a big impact on the accumulated rainfall, and the low level speed change only have a very small impact on the accumulated rainfall. And lower panel shows the relative change from the sensitivity experiment compared to the control simulation. So basically, we can see that a 10% increase in the relative humidity can produce about 20% increase in rainfall. And on the other hand, 10% decrease in relative humidity can produce 40% decrease in rainfall. So, and only 10% increase or decrease in wind speed will produce very minor changes in the rainfall. So next, please. And from the vector analysis, we can know that the moisture conversion can decompose into two components. The first one is the change due to the vapor advection. The second one is the change due to the wind convergence. So this one shows the time and the volume integrated horizontal moisture change. And we can see that it is mainly produced by the change of the wind speed convergence. On the other hand, the vapor advection have a negative but a minor impact on the moisture convergence. And if we look at the relative change with respect to the control simulation, again, we can see that the wet 10% and the dry 10% have a bigger impact on the moisture convergence. And the wind speed change only have a very little impact on the moisture convergence. Next, please. And this one shows the simulation result in terms of radar reflectivity. Upper panel shows the wet 10 experiment, and middle panel shows the control experiment, and lower panel shows the dry 10 experiment. So we can see that by increasing the low-level moisture, the radar reflectivity become much stronger and more organized. And next, please. This shows the corresponding result for the wind speed change. And again, we can see that changing the wind speed by 10% increase or 10% decrease, there is a little difference on the radar reflectivity field. So next, please. And we can also conduct a water budget study from here, as indicated in the equation here. So basically, we can say increase the moisture by 10%, have a little increase on has some increase on the total condensation, and decrease by relative humidity by 10%. That have a bigger decrease of the total condensation. And by changing the wind speed, increase 10% or slow 10%, there's only little difference on the total condensation. Next, please. And we can also look at the large scale precision efficiency as defined in this equation here. So that basically doesn't mean that the precision efficiency is defined as the total precision divided by the total vapor convergence and some local hydrometeor change. And the other way to look at the precision efficiency is from the cloud microphysics perspective. So CMPE is the total precision divided by total condensation and the local hydrometeor change. And we can also look at the condensation ratio, deposition ratio, and the evaporation ratio as defined in this equation here. Next, please. So we also can see the change of the water budget by moving the MCS system in the quasi-Lagrangian perspective. So basically, we can see that the horizontal flux convergence and the evaporation has a positive impact to increase the moisture. And the condensation, again, it will condense all the hydrometeor out of the atmosphere. So it's the negative impact. So we can see in the wet 10 experiment, there's a bigger increase in HFC and the evaporation. And for dry 10% experiment, by decreasing the relative humidity, the moisture conversion and evaporation is also decreased. And on the other hand, for the wind speed experiment, the moisture budget is about the same for between the 10% increase or 10% decrease. Next, please. So finally, we can see the change of the precipitation efficiency by moving with the MCS system in the quasi-Lagrangian perspective. So basically, we can see the precipitation efficiency is increased about 10% from the ocean to the mountain on Taiwan. That's because of the terrain lifting. Next, please. So we can see the conceptual model here by increase the low-level moisture or the wind speed that can produce the stronger convection that will have more rainfall. On the other hand, by reduce the moisture convergence or the wind speed, that would have that will produce less rainfall. And last, please. Last slide, please. Okay. So basically, we can see that the moisture convergence is more sensitive to the vapor amount, but less sensitive to the wind speed. And for the water vapor in the boundary layer, play a more important role to determine the convergence of the moisture conversion and rainfall. And and finally, we can see that by following the MCS in the Lagrangian perspective, the precipitation efficiency will increase by 10% when the MCS encountering Taiwan terrain from the ocean because of the terrain lifting. And we will further confine this moisture budget and the monsoon rainfall function in the coming summer. So we will conduct a Tahoe field project in the late May to August this year to see whether the similar monsoon rainfall water budget also occur in the monsoon rainfall in the Tahoe experience this year. This is all I have. Thank you.
Oh, very good presentation. I have one question. How did you change the wind speed?
Oh,
it's easy. Yeah, it's always easy to change the moisture in a model, but how did you change the wind speed and without, still can make your simulation stable?
Yes, I increased the wind speed by in the initial condition and the boundary condition, and we also do a PV inversion to get the reasonable change on the mass field, means the geopotential height, and
you decrease the wind speed over the entire simulation domain.
Yes.
Not only. Okay. Thank you. Other questions? Okay. Thanks a lot.
Okay. Thank you.
Now, yeah. Very nice presentation. Yeah. Now let's welcome Dr. Brent Golding from UK. Okay, Professor Brent Golding. Okay. Could you please share your presentation?
Please unmute your mic.
I cannot hear you.
You hear me now?
Yes.
Right.
Very clear.
Now I will try and share again, but it's not. Ah, okay. Okay, what do you see? Do you see the full screen or do you see half screen?
You see two screens. One
You
is
see two
yeah,
screens.
yeah.
Let's try.
We can also see the next slide. Okay, now it's good.
Good, excellent. And that changed the. You see the second slide now?
Yes.
Excellent. Right. Good afternoon, and for those elsewhere, good evening, and good morning, I guess. It's a great pleasure to join the International Monsoon Workshop and to talk about the work of the High Impact Weather Project of WWRP in the context of the severe weather that takes place in the monsoons. So here's my outline. I'm going to talk about a little bit about warnings and how valuable they are, about the role of the High Impact Weather Project and its objectives, and then I'm going to briefly touch on some extreme impact events of last year and draw some conclusions from them as to how we should be making our warnings better. What happened there?
So please load your presentation once again.
Right, yeah. Is that better? Okay. Right, so warnings protect lives and property and livelihoods and essential services from weather-related hazards. A warning is a call to action, but those actions can be very different depending on how far ahead the event is likely to happen. So if we're warning of something to happen in a year's time, the action may be to develop plans for responding to it or to train people in how to respond. As we get closer to the event, then there are preparations to be made, people to be put on standby, equipment to be prepared, and even more closely to the event, then we take mitigation action, which may be evacuation, or it may be temporary defenses, if in the case of a flood. It may be for a heat wave, setting up cooling stations, that sort of thing. And then finally, when the event happens, there's the response, and it's still useful to have a warning at the time that the event happens, because it can make sure that the response is in the right place and that it's timely and that it's most effective. And as the lead time shortens, then our confidence increases, and our precision in space and time increases, and that justifies more costly responses. So the World Weather Research Programme has been running its High Impact Weather Project for 6 years now, and the project it's part of a 10-year project. It addresses Target G of the Sendai Framework for Disaster Risk Reduction on warning systems, and it has 5 core themes that span the various disciplines that are needed for an effective warning, and it looks at a range of weather-related hazards. A distinction of the High Weather Project is that it brings together physical and social scientists broadly equally to jointly explore what makes an effective warning. So on the physical science side, we have a lot of processes that go on in the atmosphere, and they lead to features of the weather that can be hazardous. But on the other side, we have processes going on in society and internationally that lead to features of communities around the world which produce vulnerable populations. And when those vulnerable populations are exposed to hazards, that's when we get the worst disasters. So High Weather has developed a simplified conceptual model of the warning chain, which we call the 5 valleys of death. So the mountains you see in the picture here represent specific areas of expertise and often specific organizations or units within an organization. And they have special languages, they have their own jargon, and they have their own way of doing things. And they will all be very different. And if we try and communicate between them, then we get stuck along the way because the next person along the chain doesn't understand what the first person is saying. So value is lost along the warning chain before it reaches the user at the end. So what we need is bridges. And those bridges represent partnership, they represent learning each other's languages, they represent making sure our technical systems talk to each other, that our computer systems talk to each other, that we can store the data, receive and store the data from each other. And we make sure that there's nothing that gets in the way and that destroys the bridge when it's needed most in an emergency situation. So when we design a warning system, we need to understand what the problem is that the decision maker has to solve. So it isn't simply a case of predicting that a severe weather event will happen. It's understanding what the decision makers need to do if they know that weather emergency is going to happen, and what information they need in order to do that. And then the question is, well, where do we get that information from? And often what we'll find is that actually we can't do it, but we can get something similar. So we go back to the decision maker and say, can you use this slightly different information, which we can provide you with? And so it's an iterative process. And at the end of the day, everybody is happy that they can produce the information and it can be used. So that when the extreme weather event happens, we can produce that information and get it to the decision maker fast, in the right form, in the right place, and the important actions can be taken to protect people and property and livelihoods. So High Weather has brought together a vast amount of research from multiple disciplines to understand what the key issues are in opening up these bridges, building these bridges, opening up communication and partnership between organizations that produce warnings. And some of the ingredients are here. So it's the behavior of the recipient at the end of the chain that is the key success metric. That's what determines whether it's a successful warning or not. Co-design with the user ensures that the warning is both relevant to them and that they trust it. And in terms of trust, it needs to be clear what the source is, and the user needs to recognize that source. All the way along the chain, communication is as important as content, and warnings should refer to the impact of the hazard and give advice on how to respond. The hazard forecast itself needs to be combined with vulnerability information, exposure information, who and what is exposed to the hazard, what are their vulnerabilities, how are they likely to be affected. Often hazards and their impacts are very small scale, very selective, and so we need to obtain the hazards and weather forecasts at the highest available resolution. Monitoring of the physical and the social situation is important and requires high temporal spatial resolution observations from a variety of official sources and unofficial sources, including social media. Predictability, uncertainty, and confidence are critical. They need to be communicated well, and they need to be tracked through the warning chain. And for all of this, partnership between the organizations involved is essential. And to sum up all of that in a simple strapline, an effective warning is useful, usable, and used. Useful in that it has the right information, usable in that it's in a format that will reach people and be understood, and used in the sense that it enables decisions to be taken that will protect people and their property and their livelihoods. So looking briefly at the specifics of the monsoon climate, particular hazards that these things apply to are tropical cyclones and intense rainfall. Of course, with the associated flood, landslide, and lightning hazards. But drought's also important, and drought has associated wildfires, poor air quality, and heat waves. We need to know where these hazards are more frequent and intense, and how that's likely to change. We need to know who is at risk, when and where. Are rural or urban settlements more vulnerable? Which particular hazards affect the urban settlements or the rural settlements? Are people in certain occupations more vulnerable? For heat waves, for instance, outdoor workers, maybe. And which public services are vulnerable? Is timing important? Heavy rain during the monsoon is expected, but is it less dangerous when people expect it? And of course, if heavy rain occurs at night, it may be more dangerous than in the day because people can't see its effects. How can we protect people? As I said before, warnings need to be related to the ability to protect. And can we provide the information needed for these protective actions? How do we provide it? And when should we provide it? Who has the information that's needed? And who should communicate it? Is it the Weather Service that should communicate it? Or is it state governments? Or is it cities? And to achieve this, a clear governance structure is needed to make this happen and to provide the funding. So I looked at 9 individual disasters last year. A couple of them are relevant to the monsoon area. And the darkness of the green shading on this image shows the strength of the warning system. So in the case of the tropical storm in Indonesia, the tropical storm still hadn't formed. The exact location of the rain bands was very uncertain in the forecasts, and that's all the forecasts around the world. I'm not talking here about just local ones. The hazard was actually flash flood and mudslide, which is very difficult to forecast. But even the possibility of those things happening was poorly communicated. So the chain performed badly for a number of reasons, some of them inherent in the weather that was experienced, and lessons need to be learned and indeed have been learned about how that can be done better. In the case of the Henan floods in China, again, it was a rainstorm. In general terms, it was well predicted, but the exact intensity was difficult to capture. The models disagreed. Again, the communication was patchy. Some people were aware of what was coming, but others clearly weren't. And some important protective measures were not taken when they could have been. But you'll see that there were also weaknesses in storms that occurred in Germany and in North America. So there are weaknesses in all the cases that I studied, and lessons to be learned for everyone. So what are some of those lessons? Well, first of all, going back to the purpose of a warning needs to mobilize people to take action. And if people are going to take action when they're asked to, then there should be no surprises. They should know it's coming before it comes. And that's not just in the weather, but in its consequences and in the responses that will be expected of people. And those responses will be different for different people. So some with specific vulnerabilities will need to take different actions and may need to take them earlier. Particularly people who are frail or disabled, it may take much longer for them to reach safety. And to achieve this, our warnings must be delivered through trusted channels. They must reach the people who are at risk, and they must be understood by people at risk. And they need to provide advice to people on what to do and why they should take those actions. But in order to do that, our forecasting systems must deliver models that produce unbiased probability distributions of extremes. Extremes are often low probability, at least in the longer range forecasts. But if we know that the model has an unbiased probability distribution, we can be confident in providing advice. The initial conditions for our forecasts need to capture the ingredients for an extreme event, which are often a combination of unusual ingredients. Our ensemble prediction systems need to reliably identify the range of uncertainty. We need diagnostic tools for communication of low probability, high impact events. So when the probability of a tropical cyclone is only 10%, and yet if it hits you, it's going to wipe out your town, how do you communicate that? How do you get people to take appropriate action? And then we need to be able to predict the impact of these hazards. And that includes the impact on those with specific vulnerabilities. And finally, we need to measure. We need to measure the performance of our warning system. We need to know if people responded to what we told them. We need to know if those responses saved lives and whether they saved disruption to essential services, whether they enabled the protection of properties, because those benefits are what lead to investment in better warning systems. So thank you for your attention. I draw your attention to the High Impact Weather book, which is due to be published next month, called Towards the Perfect Weather Warning, and also to our Twitter, Facebook, and website, which you're very welcome to visit. Thank you very much.
Thank you. Very nice talk, and I'm looking forward to this new book. Yeah. Okay. Any questions? No questions?
Yeah, I think there are no questions. Just a minute. There are any questions? There are no questions.
I don't see any. Oh.
Yeah, there is no questions in the chat box. If directly, if anybody want to ask, they can ask. Okay, so I think there is no question. So let us thank the speaker. And so let us thank the chair, Dr. Yali, and for conducting this very nicely. Actually, there's some technical issue, but yes, it is just 10 to 15 minutes behind the schedule. But it happens, but it is scientific contents are very nice. So thank you very much, sir, and all speakers and also the chair. Thank you.
Thank you. Thank you. Okay.
Yeah, if you want to summarize anything, yeah, Dr. Yali.
Oh,
Yeah,
it's very late here in Beijing.
okay.
It's almost, yeah. So, okay, I'd like to thank IMD again for organizing this wonderful IWM-7 meeting. So, thanks, and see you again.
Yeah, sure.
Yeah.
Thank you very much. See you again for tomorrow again with different session. Thank you.
Okay, bye-bye.
Bye bye.
Okay, bye bye.